Hey there. Ready to dive into something that'll change how you think about AI? Today, we're looking at how large language models, the brains behind those chatbots you might use, can actually get smarter by learning to admit when they're wrong.
It's like building a bit of humility into these AI systems,
Right.
which ironically makes them much more powerful.
Exactly.
Yeah.
We're digging into a research paper called Thought Rollback for you,
hmm
and trust me, the concept is way more exciting than the name might suggest. It's all about giving AI the power to, well, rethink things.
The paper tackles a big issue with current LLMs, those large language models. They often stumble when tackling problems step by step, especially with tricky stuff like math. Imagine you're trying to solve a complex equation and you make a tiny error early on, it can throw off the whole thing.
Oh, I know that feeling all too well from my school days.
Yeah.
One misplaced decimal point and the whole answer goes haywire.
Exactly. These AI models experience something similar. Researchers sometimes call these mistakes hallucinations, and the problem is they tend to snowball. One error leads to another, and the solution becomes completely unreliable.
So what's the solution? We humans make mistakes too, but we can usually course correct. How do we give AI that same ability?
That's where thought rollback comes in. Think of it like hitting the undo button, but for AI's thought process. This framework lets LLMs analyze their own thoughts or steps in their reasoning and spot those errors. Then they can actually go back to a previous step and revise their approach.
So it's like giving AI the power to pause,
Mhm.
reflect on its work and say, hold on, this isn't quite right. Let me try a different approach.
Precisely. But here's where it gets even more fascinating. Thought rollback, or TR, doesn't just erase the mistake, it analyzes the error and adds it to the model's experience so it's less likely to make the same mistake again.
So the AI is learning from its mistakes just like we do. It's building up a library of lessons learned to draw from in the future.
Exactly. It's like having a mental note saying, okay, I tried that path before and it led to a dead end. Let's try something different this time.
This is blowing my mind.
Yeah.
But how well does this actually work in practice? Can thought rollback really make a noticeable difference?
The results are impressive. They tested this with GPT-4, a powerful LLM, and found it outperformed the current best by a whopping 9% on a challenging math dataset called MAT.
9%. You mentioned earlier how even a small error can throw things off. So a 9% increase in accuracy could be huge for fields like engineering or finance where those calculations need to be spot on.
Absolutely. Now, full transparency, the researchers do acknowledge that TR requires a bit more computational power. It's like it needs a bit more thinking time to analyze its steps and potential errors. But they argue that the accuracy gains are well worth the extra effort, especially for those really complex problems.
That makes sense. Sometimes we need to slow down to speed up, right?
Yeah.
But I'm a visual learner.
Right.
Is there a way to actually see how this thought rollback thing works?
There is figure one in the paper shows the difference between traditional chain reasoning, tree reasoning, and then thought rollback. It really helps to visualize how AI's thought processes can change with TR.
Okay, let's break that down for our listener. Imagine we're all trying to solve a tricky riddle. How would these different approaches work?
All right, so picture this chain reasoning is like following a single line of logic step by step. If you make a wrong turn early on, you're stuck on that wrong path. It's a bit like those old choose your own adventure books where one wrong choice and it's game over.
Ah, yes. Those books were a roller coaster of emotions, especially when you hit a dead end. So what about tree reasoning?
Tree reasoning is more advanced. It's like having multiple paths branching out at each step so you can explore different options. But it can still be pretty rigid. You're limited to those predetermined branches.
So thought rollback is like having a map where you could freely move back and forth, explore different routes, and even draw new paths if needed.
That's a great way to put it. With TR, the AI can backtrack, reassess, and try new approaches dynamically. It's much more flexible and adaptable, and Figure 1 really highlights that visually.
Okay, that makes sense. But can we give our listener a more concrete example, something they can really relate to? Maybe a real-world problem where this undo button for AI would be super helpful.
Absolutely.
All right.
The paper uses a great example where GPT-4 with TR tackles a tricky math problem. It's about figuring out how many buses you need for a school trip. You know, the kind of problem that makes you wish you'd paid more attention in math class.
Oh, I remember that one. The model actually makes a mistake at first, right? Like a classic rounding error?
Yes.
Yeah.
Initially, it rounds a number up incorrectly, leading to the wrong answer. But here's where thought rollback shines. The model realizes its mistake, goes back to the step where it rounded, and using its experience corrects itself.
So it's like the AI is thinking, wait a minute, I've been down this road before. Rounding up here always leads to trouble.
Exactly. It learns from its past mistakes, adapts, and arrives at the right answer. That's the beauty of thought rollback. It mimics human problem solving in a way that's both fascinating and incredibly powerful.
It's making me rethink how I approach problems, too. This is so cool. But I'm also curious about the bigger picture. We've seen how TR works, but what does this mean for the future of AI? How will this ability to learn from mistakes impact the kinds of problems AI can solve?
That's a great question, and it takes us to the heart of why this research is so important. Let's explore that in the next part of our deep dive. So, you're curious about the future of AI, right? What's so exciting about thought rollback is that it isn't just a cool trick for solving math problems. It has the potential to revolutionize how AI tackles all sorts of challenges.
Okay, now you've really got my attention. Give me some examples. What kind of real-world problems could TR help us solve?
The possibilities are pretty much endless. Think about scientific research, for instance. Imagine AI models that can sift through mountains of data, develop hypotheses, design experiments, and then here's the kicker, revise their entire approach based on the results they get.
So it's like having an AI research assistant that's constantly learning and refining its methods, just like a real scientist would.
Exactly. It could dramatically accelerate the pace of discoveries in all sorts of fields, from medicine to climate science. And it's not just limited to science. Think about things like writing complex code, designing new products, even composing music or creating art, all tasks that require creative problem solving and the ability to learn from mistakes.
Wow, so this isn't just about crunching numbers. It's about giving AI the tools to be more creative, adaptable, and ultimately more successful.
Precisely. Now, to answer your question about how well TR actually works, the researchers put it through a series of rigorous tests. They used a bunch of different data sets, basically collections of problems designed to really challenge these AI models.
Okay, so like AI boot camp. What were some of the challenges they threw at it?
Well, they used several math-focused data sets, including GSM-8K, SVAMP, Aqua-Arat, and of course math, the one we mentioned earlier, where GPT-4 with TR saw that 9% improvement. These are all standardized tests, so you can compare results across different models and approaches.
So it's not just about getting the right answer.
Right.
It's about comparing how different AI systems perform on the same challenges, right?
Exactly. And what they found is that across these different math data sets, LLMs equipped with thought rollback consistently ranked among the top performers. They were going head to head with some of the most sophisticated AI systems out there and holding their own even on problems that would trip up most humans.
That's impressive. But earlier you mentioned that TR requires more computational power. Did that impact how quickly it could solve these problems?
That's a great question. While it's true that TR might use more tokens, which is a way of measuring the computational effort, it often solves problems in fewer steps.
So it's like it takes a little more time to think things through,
Yeah.
but because it can backtrack and avoid those dead ends, it ultimately gets to the right answer faster.
Exactly. And that's really important when you're thinking about applying AI to real world scenarios. You don't just want accuracy, you also need efficiency.
Of course, time is money, as they say. Were there any specific challenges where thought rollback really stood out? You know, those aha moments where you could see its potential shining through?
Definitely. One that comes to mind is the math dataset. They tested how TR performed on different levels of difficulty within that dataset. And as you might expect, the harder the problems got, the more work TR had to do, more rollbacks, more analysis, more tokens used.
So it's like when we're tackling a tough problem, we have put in more effort, scribble out more notes, try different approaches. TR is doing something similar, just digitally.
That's a great analogy. And here's the cool part. Even on the most difficult levels of the math dataset, GPT-4 with TR was able to keep up with and even outperform some seriously advanced AI models, including some that use external tools like code interpreters.
So it's like thought rollback is leveling the playing field, allowing these LLMs to compete in the big leagues of AI problem solving.
Exactly. And that was further confirmed when they tested TR on a dataset called Theorem QA. This one focuses on problems that require logical reasoning and applying those complex mathematical theorems you might remember or try to forget from advanced math classes.
Okay, so this is definitely next level AI going beyond basic arithmetic and into the realm of proving theorems. How did TR handle that challenge?
It excelled GPT-4 with TR significantly outperformed the reigning champion model on Theorem QA. It was a clear demonstration that thought rollback can equip AI to tackle even the most abstract and intricate mathematical concepts.
I'm sensing a pattern here. The tougher the challenge, the more thought rollback seems to shine. Are there any other examples that really highlight its problem-solving prowess?
There's one more I think you'll find particularly interesting. It's called the Game of 24 dataset.
Wait, isn't that the card game where you have to use 4 numbers to make 24? I remember playing that in school. It can get surprisingly tricky.
Yes, exactly. And it turns out to be a fantastic test of numerical reasoning and flexibility in problem solving. What the researchers discovered is that TR dramatically reduced the failure rate in the Game of 24, particularly in those early steps where you're trying to figure out a viable path to the solution.
So it's like TR is helping the AI avoid those frustrating dead ends early on, which leads to more successful solutions overall.
Precisely. Now, on this particular data set, they did find that TR benefited from a little bit of guidance in the form of what they call CR prompts.
CR prompts, can you explain what those are?
Think of them as hints or examples that give the AI a little nudge in the right direction, specifically tailored to the Game of 24. It's a bit like having a coach whisper a strategy or two before you step onto the court.
So it's not about giving the AI the answer, but rather providing a framework or a way of thinking about the problem that helps it get started.
Exactly. And when they added those CR prompts, the performance of GPT-4 with TR skyrocketed, achieving a remarkably high success rate on the Game of 24.
Okay, so even with a little coaching thought, rollback can make a big difference. It's like having a superpowered study buddy for your AI.
Mhm.
But we've been focusing on the technical side of things. I'm curious about the bigger implications here. We've seen how TR works, how it performs, and the kinds of problems it excels at. But what does it all mean for us humans? How will this impact our lives, our work, our future?
That's the million-dollar question, isn't it? And I think it's one we need to explore carefully. We're talking about giving AI the ability to learn from its mistakes, to adapt, to become more efficient and accurate in its problem solving. The potential benefits are huge, but it also raises some important considerations.
Okay, now you've really got me thinking. Let's dive into those considerations in the final part of our deep dive. All right, so we've established that thought rollback is a game changer in the world of AI. But what does it actually mean for us humans? How does this impact me, the listener?
That's the key question, isn't it? It's easy to get caught up in the technical details, but what really matters is how this technology can change our lives for the better. And I think the answer is, in many ways,
Okay, give me the rundown. Where will we see the biggest impact?
on a practical level, thought rollback could revolutionize fields that rely on complex problem solving. Imagine the possibilities in scientific research AI models could analyze huge amounts of data, formulate hypotheses, design experiments, and then crucially revise their whole approach based on the results. It's like having a superpowered research assistant that never stops learning and refining its methods.
So it's like accelerating the pace of scientific discovery, helping us find new cures, new energy sources, solutions to some of the world's biggest challenges faster than ever before.
Exactly. And it's not just limited to science. Think about software development. With TR, AI could write more efficient and bug-free code, which would make all the apps and programs you use every day run smoother and be more secure.
Okay, that's a benefit I can definitely get behind. No more waiting for that spinning wheel of doom while my computer tries to figure things out. What else?
Think about product design. Imagine AI helping engineers create safer cars, more efficient airplanes, or even entirely new gadgets we haven't even dreamed of yet.
I'm starting to see how this could touch almost every aspect of our lives. But with AI becoming so powerful, how can we be sure we can trust it? If we're relying on it to make important decisions, don't we need to understand how it's thinking?
That's a crucial point, and it's something the researchers address directly. They emphasize the importance of transparency and explainability in AI systems. It's not enough to have a black box that spits out answers. We need to be able to understand how those answers are reached to ensure that the AI's reasoning aligns with our values and ethical considerations.
So it's not just about creating smarter AI, it's about creating AI that we can understand and collaborate with and trust.
Precisely. And thought rollback is a perfect example of how AI development can be inspired by human strategies. We humans have been using adaptive reasoning for centuries, learning from our mistakes and refining our approaches. Now we're teaching machines to do the same.
So it's not about AI replacing human intelligence, but about augmenting it, giving us new tools and insights to solve problems together.
I think that's a brilliant way to put it. TR shows us that AI can be a powerful partner in problem solving, helping us achieve things we couldn't do alone.
We've covered a lot of ground today, from the technical details of thought rollback to its potential impact on science technology and even everyday life. But before we wrap up, I want to leave you with one final thought to ponder.
I'm all ears. What's the takeaway you want our listener to walk away with?
We've talked extensively about AI learning from its mistakes. But what if we flip the script? If AI can learn to course correct so effectively, what does that tell us about our own approach to problem solving? Are we as willing to admit when we're wrong to backtrack to try a new approach?
That's a profound question. Perhaps this AI development can be a mirror reflecting back to us the power of embracing our own fallibility. Maybe learning from our mistakes isn't a weakness, but the key to unlocking even greater human potential.
And who knows, maybe AI can even help us do just that. Thanks for taking this deep dive with us today. Until next time.